Welcome to another video, and here is our math challenge for today. We want to find the value of x in cos of 90 plus x equals cot x. To solve for the value of x here is very simple, but what we take note first is whenever we have or anytime we have cos of, suppose we have pi divided by 2 plus theta. This is equivalent to minus sine theta. And again, if you have cos cot theta, this is equals cos theta divided by sine theta, and all this one they are just like an identity. All right, so let's do the replacement. We have minus sine x equals cos x divided by sine x as the question implies. And know that pi over 2 is still 90, and again when we cross multiply at this stage, we are going to have this as minus sine x multiplying sine x equals cos x. So multiplying these two together, we have minus sine square x equals cos x. And again, let's try to take minus sine square x to the right hand side, or let's say we add sine square x to both sides, so still the same thing. And here we have cos x plus sine square x equals 0. On getting to this stage, we need x, and let's make all this to be uniform by recalling that sine square x equals 1 minus cos square x. And we do the replacement. Then we have 1 minus cos square x plus cos x equals 0. Therefore, let me multiply out 2 by negative for us to have minus 1 plus cos square x minus cos x equals 0. Therefore, we are going to do the rearrangement as cos square x minus cos x minus 1 equals 0. So the reason for this is we want to get a quadratic equation, and we have gotten it. Okay, let's try to compare this with the general quadratic equation, which is ax squared plus bx plus c equals 0. And by comparing these two together, we are going to see that the value of x here is just like cos x, and we are going to have a as the coefficient of x squared, which is coefficient of cos square x, and we have it as minus 1. Then we have c to be minus 1 as well. Therefore, the general quadratic formula is x minus b plus or minus b squared minus 4ac divided by 2a. We are going to plug all these things in this. Remember, our x is still cos x. So by replacing it, we have cos x equals minus, and b is minus 1 plus or minus the square root of minus 1 square minus 4 bracket a is 1 and c is minus 1, all divided by 2 bracket 1. Therefore, we have cos x equals minus times minus is plus, and we have 1 plus or minus the square root of 1 minus times minus is plus, and 4 multiplied by 1 multiplied by 1, that is 4, all divided by 2. Then we have cos x equals 1 plus or minus root 5 divided by 2. If this is the stage you got, there are two possible things here. Either we let cos x equals 1 plus root 5 over 2 or the other. So let's deal with the positive side first. We have cos x equals 1 plus root 5 over 2, and to get the value of x, we take the cos inverse of both sides, and therefore we have x equals cos inverse of 1 plus root 5 divided by 2. But let's know something here, that this is going to lead to our complex solutions, and which is not the valid solution for this, as x is a member of real number, not complex number here. So for the second one, which is 1 minus root 5 divided by 2, so we do the same thing by taking the cos inverse of both sides, and therefore we have x equals cos inverse of 1 minus root 5 divided by 2, and which indeed this is a real solution for the value of x, and is positive because cos is even functions. This is how to do this problem. I hope you learned something today. Thanks for watching, and please don't forget to subscribe to this channel for more exciting mathematics questions like this. If you have another way of doing this or any other perspective looking at this, you can drop it in the comment box. I will see you in the next class. Never stop learning. Bye bye.